Okay, so to this point, we actually assume, remember, that the G is something that the government spend. And those spending, like I said before, you can assume that's going to be a waste. You just dump them into the sea. That doesn't really matter. Okay, you can consider that as thrown away. It's totally a waste. Okay, we do this assumption because there, you sort of don't really care about those spending. We're not focusing on the choice of government spending. We focus on the choice for consumption and leisure, and also focus on how much in production that in equilibrium the model will produce. Right? But and actually, in economics way of thinking, there are spending that in our society that looks like that works that way. Okay, for example, national defense. Unless we are like Ukraine, where we actually have a war. Otherwise, I mean, in the past few decades, we don't have any war, right? So all government spending on national defense is just like throwing those resources away. You're not really make them really helpful in any way, any people's life. Okay, except maybe for those military who earn those salary. Okay, so but there are public goods that really benefit us. For example, government also build park, or public transportation, or health services. Like we have the national health insurance, right? That's also government spending. Okay, and those provide direct benefit to the private sector. In other words, the G doesn't mean the G is not something that's thrown away. G is gonna benefit those consumer. Okay, we're gonna look at this model, and this model will tell us how much is the optimal level of government spending. In other words, how large should the government be? That's the main question we'll discuss here. That's a very common political debate, at least in the US. That's a very common political debate. The Republican, generally speaking, argue for a small government, and the Democrat argue for a big government. Okay, that's the difference between the government size. Okay, so in this model, okay, the government spending is gonna be there's no firm basically. We don't have a firm here. We remove the firm. So the representative consumer's budget constraint become really simple. Okay, he or she receive amount of output Y. This output you can assume that's a output coming from heaven, from God. Just drop on your head every day or every year. You just receive a Y, and then you use that to consume and to pay tax. The tax here, we also assume that is a lump sum tax. Okay, so that is not a proportional tax here. And for the production possibility from here, we assume that G is actually QT. What does that mean? Is G is a proportional of the total tax. What it means is this G is not like the previous G we talked about. This G is something that will benefit the consumer, park, public transportation. But because if the government collect, for example, $100 of tax, this $100, because the government is not that efficient, right? Also, there are some intermediate costs there. So it cannot be the case that the government collect $100 of tax and spend on the transportation, and everybody is totally benefit for amount of $100. There must be a discount. So if the government spent $100, maybe the discount is 10%, then Q is 0.9. Is that clear? Okay, the idea here is that, remember, G is different from the previous G. Now G, you can think of it as how much the consumer enjoy or spending on the or not enjoying the public transportation, park, or any public services. Okay. And if G is QT, then T is G divided by Q, right? So this T can be replaced by G divided by Q. So you get C equals Y minus G divided by Q. That's your production possibility from here. Again, PPF is the relationship between C and Y. Okay? Here is C and Y because Y is the total production. Okay, there's no labor here. Okay, remember, I forgot to say this, but there's no firm here. So the output is just coming up from heaven. So the person doesn't work. There's no choice of time. Okay, the person doesn't choose how many hours to work. Okay, and here we assume that the government chooses G to make the representative consumer as well off as possible. G is chosen so that the marginal rate of substitution of private for public good equals the marginal rate of transformation. What that means, it's better to look at the graph. It will be clear. This is the PPF. PPF, this one. Here, this is C, this is G. Oh, sorry, it's I say it wrong. It should be relationship between C and G. Because here, C and G is what the consumer enjoy. Y is a exogenous variable. So I correct myself. Like I said, my head is not really clear today. Sorry about that. But it should be a relationship between C and G. Okay. And if it's a relationship between C and G, here it should be clear that C equals Y minus Q, 1 over Q, right? And times G. So this is the slope. And this is also a linear curve. Okay. So you'll see that this is QY when G is, when C is 0. When C is 0, Y is G divided by Q. G is, what I'm saying. G is Q times Y. And when Q is 0, C obviously equal Y. So when Q is 0, this is Y. And when G is 0, C equals to Y. And when C is 0, G equals to Q times Y. So slope here is QY over Y is Q 1 over Q, right? Okay, so this is a linear curve. And this is consumer's budget constraint. Consumer's indifference curve. So the government is going to choose a optimal G level. Remember, the G level will decide how much tax you collect, right? Because G is QT. So, and C equals to Y minus T. So obviously if you increase the G, the T have to increase. And T increase means your consumption is going to go down. So it's on this line, right? And the government is going to choose the G level, and basically that will decide the C level. So government only decides the G, but that will eventually decide how much the consumer can consume. And government will try to maximize the consumer's utility. Okay. So what happened if when Y increase, The amount of output that coming from heaven goes up. Similar to what we previously discussed, that's a pure income effect. Basically, the consumer is getting wealthier. Okay, so the private consumption and the government spending both go up. And wealth, so that's the implication here is that wealthier countries usually choose to have a larger government. The larger government here means G is larger. But usually when we talk about larger government, there's another way to say, to define the larger government. That's your G over divided by Y. That's how much percentage of your GDP is spending on government. It's the government spending. That is not clear whether it's increase or decrease. Because Y increase, right? And Y increase and will lead to increase in G, but it depends on the proportion between these two. Okay, so this is what it looks like. A Y increase will go like this. And then the optimal point go from A to B. Pure income effect. Okay. And how about the slide I put on NTU Core is a newer version. This is an older version. I forgot to update the one in my iPad. For government what if the government become more efficient? What does that mean? That means the Q increase. So before maybe $100 is transferred to $90. That's Q equals 0.9. Now maybe Q is 0.95. That means $100 will become $95. Okay. Remember, Y doesn't change. Only Q increase. So Y doesn't change, but Q increase. So it goes like this. So it's a pivotal change. And similar to what we had before, this is again, there's an income effect and there's a substitution effect. Okay, so here you can see that the original optimal point is here and the new optimal point is here. And in this case, we see that both G and Y increase. But if we change this model a little bit, it can be the case that G doesn't increase. Because the income effect tells you to increase G, but the substitution effect tells you to decrease G. From D to A, that's the substitution effect. From A to B, that's the income effect. Okay? So G increase, sorry, I say it wrong. Sorry, I'm really dizzy today. I'm not in my best status right now. Actually, it's the opposite. It's the G will increase, but let me see why. Okay. Doesn't look like that way though. Maybe my slide is incorrect. Oh, yeah, my fault. This is the original optimization point. Okay, this is the original PPF. So the government choose the level to optimal the consumption bundle at A, and the new optimal consumption bundle is B. So from A to D, that's the substitution effect. From D to B, that's the income effect. So the income effect tells you C increase, G increase. But the substitution effect tells you increase G, but decrease C. So G must increase, but the C is not sure. You're not sure about C. Okay, so G increase, but private consumption, that's C, may increase or decrease. Okay, so this model, what's the trick here? You can consider that, so the difference between this model and the baseline model we talk about in chapter 5 is that here government is basically choosing the consumption level and the G at the same time for the consumer, right? And we assume sort of that the government knows the utility function of the consumer, right? So that it knows the indifference curve, and the government can optimize for the individual. But in the real world, even the model is as simple as this one, the government might not know your indifference curve. Actually, I mean, even if we can really produce something called a representative consumer, the government might not know, right? And in that case, the government might have an incentive to increase the government spending, and that will cut the consumption. So that means government have an incentive to increase G, and so it might end up choose a point here. Then obviously the utility level for the consumer is actually lower. Okay, so there's no guarantee that the government knows the utility function of the consumer, there is no guarantee that there is a optimal level of government spending. Okay, remember in our baseline model, we don't need the government to know anything about the consumer, right? The government only decide how much they need to spend on G, which decide the lump sum tax, and the lump sum tax will be an exogenous variable that decide how much but the person still have the choice between consumption and leisure, right? Consumer will choose between consumption and leisure and maximize his or her own utility. So we only need the consumer to know his or her own utility, and we only need the firm to know that the firm pay off the pie so that it can maximize that pie. The firm doesn't need to know anything about the consumer doesn't need to know anything about the firm, and the government doesn't need to know anything about the firm and the consumer, but we can still have a competitive equilibrium. There we don't have this kind of problem, but here there's a problem. So in the perfect world, the government can choose the optimal level of consumption and government spending. Okay? That's it for today.